Okay, good evening, everyone. I think we might as well get started. Welcome to week 4 of our short course for CCNA security. Tonight we're going to talk about IDS technologies. Mainly, it's pretty much a lot of this is a theory lecture, and the reason that is because there's more coverage of theory type topics on the CCNA security exam as opposed to actually configuring of IPS. I will be going through a quick lab towards the end of the evening, and I'll again it's a packet tracer lab, so I'll pop that up onto Moodle for you to have a look at and have a go at, but most of the things we're going to talk about tonight are just from a theory-based perspective. Okay, so objectives of tonight's lecture. We're going to compare and contrast IDS and IPS. Okay, what are the differences? It's important that you know that for your exam, for your CCNA, the official CCNA security exam. We need to define some IDS and IPS types and options. And we're going to compare network-based and host-based IPS systems, so HIPS and NIPS as they're known. Okay, so first of all, IDS. So intrusion detection system can be a hardware or software-based solution that passively listens to network traffic. Okay, the IDS is not generally inserted inside the traffic path, but it listens promiscuously to all traffic on the network through a monitor port. Usually you'd only have one promiscuous interface. That's the only requisite you need for network monitoring, but you can have multiple promiscuous interfaces if you want to monitor multiple networks at the same time. So when the IDS detects malicious traffic, it'll send an alert to a configured management station, and we'll see that actually in the lab where we'll be sending it off to log servers. IDS have limited active response capabilities. Okay, so they can monitor, they can generate alerts and events based on different types of traffic they see. They can, when it's configured, some of the Cisco models are capable of blocking further malicious traffic by actively configuring network devices. So, for example, security appliance or routers. So what we can do is we can actually set up our IDS to when a certain threshold is reached or a certain event is seen, it can actively push out certain pieces of configuration to other networking devices to try and cut that traffic off at the knees. However, once the original malicious traffic has already passed through the network through to the intended destination or the end target, then obviously you can't do anything about it. So it's a reactive thing, as most things in security are. But of course, subsequent traffic to that particular host of that nature will be blocked. IDS generally also have the capability of sending TCP resets to the end host to try and terminate any malicious sessions that are coming in. But again, it's not in line, sits off to the side, promiscuous port, listen. You can, in some circumstances, configure them to do some sort of active configuration, but generally they just sit there and alert and send off to a log server for you to interpret at a later time. IPS, on the other hand, and let's get all the points up first. So an IPS is an active device that sits inside the traffic path. So as you can see in the diagram here, the IPS is actually sitting in line with the corporate network, so behind the firewall, but in line with the direct traffic path coming from outside the firewall inside to your corporate network. So it listens to all the network traffic and permits or denies the flows and packets through that part of your network. All traffic has to pass through it. It arrives on one interface and exits out another. So with IDS, we might have you'd have a management interface which would be out of band. Okay, so on a separate network or a separate VLAN or DMZ or however you want to term it, and then you would have a promiscuous interface which would actually listen to the traffic as it's coming down the line. IPS, by comparison, so part of our compare and contrast here, is that it will sit in line. Okay, so the incoming cable from the inbound interface on the firewall or router will go into the inbound interface on the IPS, and then there's an outbound interface on the IPS which connects into your network. So all traffic has to filter through it. Now some may say, and it's a good point, you might raise the point that because it's in line, it represents a single point of failure, and it does indeed. In most cases, most high-level IPS vendors selling products nowadays allow certain circuitry, there is specialized circuitry that's built into these devices such that if they do fail, they will fail open, or some of them you can configure to fail closed. Obviously, if they're configured to fail closed, you're going to know about it pretty soon, but you then need to have something very close, hot swappable or warm swappable, ready to go as soon as that happens, because otherwise your network becomes unusable. That may not be an issue if you're only using outbound internet or inbound internet, but if you're serving a lot of web, if you've got a lot of web servers or you're accepting a lot of mail, it could be a big serious problem. And if you're an ISP, for instance, that could be a really big issue. So in most cases they would probably fail open, and you could also have multiple occurrences of these too. So you might have two inline IPS. So the first one, okay, through it goes. If it fails, the second one will automatically take over. So it doesn't necessarily mean they're cascaded in line. It just means that they're both sitting there, both active, have active paths through the network, and use some sort of load balancing algorithm out the front to be able to accept constant connections depending on which is up and which is down, but they're sitting there ready to go straight away. Just a question I see, what tool does the IDS IPS use for collection of traffic? Is it Snort? In the Cisco environment, no, it's not Snort. It's their own proprietary software. Snort is a very valid and very useful tool, and I believe Cisco have actually purchased them in any case, but it's not a pure version of Snort as you would have seen it previously as Snort. It's now been completely Cisco-ified and made proprietary, although they still have that option to download, the free versionware, which will run on any sort of PC platform as we've had before. Another quick question, can a network have both IPS and IDS? Absolutely, you can. That's completely valid. In most cases nowadays, though, an IPS will have all of the features of an IDS anyway. So if you have IPS, you get the whole box and dice, so they're really an expansion of an IDS. Having said that, there's no reason why you couldn't have an IPS in line for your internet traffic coming through, but then have an IDS sitting out monitoring promiscuously all the traffic that's coming into your DMZ, for example, or in other specific VLANs that you would like to protect across your network. So whether that's a HR VLAN or a I'll get it out in a minute, payroll, something like that. IPS, another question, is it a kind of protocol? No, it's not. IPS stands for Intrusion Protection System. So it's just a device that does intrusion protection. Now, IPSs will add a little bit of latency to your network. Yes, that's a byproduct. I mean, any device that you have where traffic will pass through will obviously introduce some form of latency, but they're very high end. Often they will run inside a chassis, so something like a 6500, an 8500, or something larger. And these guys have an awful lot of backplane bandwidth available, and they go extremely quickly. So the introduction of latency is negligible. Okay, so if we want to combine IDS and IPS, which we can do, as one of the questions just asked. So they're complementary technologies, as I said. So they're often deployed in parallel in enterprise networks. The IPS will actively block offending traffic and can be considered really like another implementation of a firewall system. IPS have to be tuned to block only known malicious traffic in order to avoid what's called a false positive. So a false positive is when you block something that actually wasn't malicious at all. Okay, so you're stopping something from coming in that actually was legitimate. So that's a false positive. A false negative, on the other hand, may actually be more dangerous. And that's when you say, okay, no, that's not malicious traffic, I'll let it in, and it turns out to be something, not very good at all. So you need to be careful. But whether it's an IDS or an IPS, IDS will just monitor, IPS will block. They need to be tuned so that they learn about the traffic that's coming through your network, and this is typically the process you first do when you put them in. You'll put them in line and just put them into listen-only mode, into a learn mode, and they will accept traffic. They will build up an idea of what typically comes through your network and start to learn from that. Okay, then you'll go back into the configuration, have a look at what's been logged, and say, okay, well, I don't like that, I don't like that, I don't like that. Select what you do and don't like, and away it goes. So hence it needs to be tuned. So an IDS can be used in conjunction with an IPS to verify that what the IPS is really blocking is actually malicious traffic. Okay, so they can verify each other, they can bounce off each other. When I say that they don't do that automatically, that's something that you have to do as a network technician. In addition, IDS can also be configured to send alerts about grey area traffic. Okay, so that's data that is not clearly malicious, but we're not sure if it's legitimate as well, so it's called grey traffic. In that sort of case, when you see grey traffic, we don't want that to be blocked by the IPS because it could be legitimate. Okay, so we've got to be careful what we consider as malicious traffic. But it still alerts on that traffic to be able to give you some idea of A, what's coming into network, and B, give you an opportunity to classify that grey traffic as being potentially malicious or okay to pass through, if that makes sense. I'll just hold off on answering questions for a few minutes, guys, till I get a bit further, because I think some of them will be answered further on. Okay, so iOS IPS products and technologies. So what sort of products does Cisco offer? You do need to know a little bit about these for the exam. There's a number of different flavors that Cisco offer for iOS-based IPS and IDS. So firstly, they've obviously implemented the IPS functions into their iOS, okay, their router and switching software. So it combines existing IDS and IPS product features together with 3 different intrusion detection techniques. So the iOS IPS uses a blend of IDS and IPS products from the IDS and IPS sensor product lines. Okay, so what we're saying is it'll take, because you can buy, as it says here, you can buy appliances, so they're a specific piece of hardware that's either IDS or IPS. You can also buy service modules, okay, which are the modules that click into your routers, or your network modules, which are the big ones that click into your routers, okay, the full width, the full slot width of service modules are the little ones. Okay, so you can pop those into your existing routers and add that IPS functionality on top. So as I said, there's a blend of intrusion detection products that it uses. And it uses they use the following 3 detection techniques. So and we'll briefly have a look at some of these as we move further into the class. So we have the profile-based intrusion detection, okay, which this generates an alarm when activity on the network goes outside a defined profile. So you have to set up your profile first. This is what we consider as normal. If traffic coming through your network steps outside that boundary, then alarms will be generated. So with anomaly detection, which is what this is called, okay, if it goes outside predefined boundaries, it's an anomaly, it's anomalous traffic, therefore it's called anomaly detection. So profiles are created for each user or user group on your system. And so you can see you can get it fairly granular. So these profiles are then initially used as a baseline to define your normal user and normal network activity. So as I said before, these devices need to be tuned. They need to learn what is good and what is bad in your network, because all networks are unique. There's unique traffic patterns for all networks, whether that's type of traffic, volume of traffic, direction of traffic, There's lots of different things that need to be, as with all good engineering, all good network engineers will know, the answer to any question is usually it depends. And these guys are no different to that. They need to be tuned, they need to work out what's actually happening in your network. And it depends on what you're doing with your network, what you're trying to achieve. So we use these profiles as a way for the IDS or IPS to learn and build up its knowledge base of what is normal or abnormal on your particular network. And then you'll say through the configuration interface, yes, that's okay, or no, that's not okay. So that's profile-based intrusion detection. Then we have signature-based intrusion detection. So this is a little bit like AV. Okay, so it's less prone to triggering a false alarm. And basically, a signature is a set of rules which can be applied to typical intrusion activity. Okay, so it may know that if you're getting say for instance you're getting a denial of service attack, there's a certain pattern to that. There's a certain pattern to denial of service attacks or to Smurf attacks or whatever, scan, whatever it is. There's usually a certain set of things that will always happen in a particular, that will often, not always, I shouldn't say that, will often happen in a certain order. And so signatures are created a bit like an AV signature in that they look for certain types of patterns in the traffic. And once they've seen that, then they will start looking more in depth and they'll start to monitor, they'll start to alert, they'll start to send alarms, and then they'll start to perform whatever action you configure the IPS to do once that certain signature is seen. Okay, then that's all I want to say about that. So the last one is protocol analysis-based intrusion detection. So it's similar to signature-based detection, but it performs more in-depth analysis of the protocols specified in the packets. Okay, so it's deep packet. Okay, it's much more deep packet than what signature analysis is. So the deeper analysis examines a payload within the TCP and UDP packets, as we say, deep packet inspection. And a good example of that is DNS. Okay, so it could be TCP or UDP, which in itself is actually contained within an IP packet. So it has to dig further into the packet to be able to see that. Now, I'll just pause for a minute and just answer some of the questions here. CCNA security covers Cisco iron ports. Not specifically. It's a little bit more generic with what's actually in the exam. Typical throughput of these devices, it depends on what router platform you're running on, because remember we're talking about iOS devices. So say for instance if it's a 3900 series router, well then it's going to be it's going to have more throughput than say a 2800 series or an older version. Okay, so it depends on, and a 6500 again, if you've got these modules in a 6500, then that's obviously going to be have a much higher throughput. So it depends. It all depends on the platform you're actually putting it in. As far as the appliances go, off the top of my head, I'm not altogether sure. They are fairly high range though, talking fairly high throughput rates, but I can put up a link for that for you to go and explore that a little bit more in depth. Remembering that the CCNA exam doesn't talk about so much the appliances, they're more interested in the iOS side of it. Can you get IPS with layer 7 DPI? Yes, you can. Does it detect unanalyzed traffic? I'm not sure what that's actually asking. The IPS will detect anything that you configure it to detect. Some of the signatures are slightly heuristic in nature, so they use what's called rules of thumb traffic patterns, and then they will learn to a certain degree about other variations to that pattern and may be able to detect it. But again, security is always going to be a reactive type process. Okay, what else we got? Some IPS blocks some kind of, IPSs, if they're poorly tuned, can block some legitimate traffic, absolutely, and they can also let through traffic that is not legitimate. So the security devices are, the IPS are no different to any other security device in that if you configure them poorly or don't have them set correctly, don't leave them learn long enough for your particular network traffic patterns, then yes, they will give you grief. There's no doubt about that. One of the most common issues people have when they configure these devices is that they don't leave them inactive, so to speak, for long enough to learn the traffic patterns that are coming through their network. Sometimes, some connections, particularly in large enterprise networks or service providers, some connections might, only be very spasmodic. May only happen once in a blue moon or once every 2 or 3 weeks. So if you put in an IPS and you start tuning it, and then you say, all right, well, after 3 or 4 days we're going to send it live, then you could end up with some problems later on down the track. So it's one of the common issues that people don't let them learn long enough to get the best value out of them. Now, I'll just okay. There's a couple of questions here. So what do ASAs have, IPS or IDS or something else? I get very confused between the difference between ASA and iOS devices, and why do you choose one over the other? That is a fantastic question. Thank you for asking that. So ASAs have a small component of IPS and IDS built in them. They look for some signatures, and they do some anomaly detection, but it's to a limited degree, because at the end of the day they're a firewall. Okay, so their job is to block traffic based on the security profile or policy that you configure on it. So their job is not to sit there and analyze the traffic coming through and say, oh, I think that's anomalous or I think that's bad. They're a firewall. IPS and IDS take that functionality way past what an ASA can do. Okay, so an ASA does have a small proportion of IPS and IDS built into it, but only limited. An IPS IDS, on the other hand, looks at traffic patterns. It loves it. That's what it does for a living. It sits there and it pulls the traffic apart and it thinks, okay, well, that's not what I usually see, and that's a bit anomalous, and hey, hang on, there's a signature there that I don't like, and it blocks. Or it sends messages to other devices, such as firewalls or routers, and allows them to dynamically block traffic as it comes through. So its job is not to be a firewall. It won't sit there necessarily, depending on how you configure it, and block traffic. Okay, it'll just tell someone else to block it. So it's a bit like the guy who's sitting there reading through the paper or reading through the book and then say, oh, don't like that, take that bit out. Okay, now the difference between an ASA and an iOS device is simply that an ASA is a purpose-built appliance firewall. An iOS device, such as a router or a low-speed switch, such as a 6500, something like, or other chassis-based switches, are primarily routers and switches. However, you can build some firewalling capability into them. And again, it's a horses for courses type question. So if you have a small network, you might go with a router that's got some firewalling licensing on it, so you can run a bit of the firewall stuff and have a bit of it. And basically all it is access lists, some form of an access list. And you can run a bit of iOS, IPS or IDS on it. Great, that's great. If you've got a bigger network and you want more security or higher level security, instead of having your firewalling and your IPS on a single platform, you might say, all right, I'll let my routers do routing because that's what they're good at, and I'll get myself an ASA firewall and use that as a firewall because that's what that's good at, and we'll also buy an IPS appliance, okay, or an IDS appliance because that's what they're good at. So again, there's these different levels of scalability that you can have in this particular space. So if you've got a small enough network that hasn't got a bucket load of traffic going through it, or you've only got a single internet connection or something, or something's fairly simple, then you can just use an iOS router with a little bit of firewalling and a little bit of IDS on it, a little bit of intrusion detection, and that's fine. It's all about the scalability. So if you think about a router is a router that you can have firewalling and IDS on. An ASA is a firewall that you can have a little bit of IDS on if you want, or an IDS is an IDS, but it doesn't do everything the firewall does, and it's no good to put it in the center of your network and expect it to do all your EIGRP or OSPF or BGP routing. Okay, so different devices, horses for courses. Okay, it's just a question about labs, about simulating IDS and firewall simulations. There are some capabilities inside Packet Tracer to do this, but they're very limited and mainly confined to iOS devices. Again, packages like GNS3 can be manipulated so that they can act as an IDS, but the issue with that is you always need to have access to licensed version of Cisco software before you can actually use GNS3 to its full capabilities. Just a point, no, the screen isn't moving at the moment because I'm answering some questions, so it'll move just shortly. Integrate open source syslog with IPS IDS, absolutely you can. Doesn't matter what your syslog server is, you can send syslog messages from a Cisco IPS IDS to any syslog server, that doesn't matter. Okay, does Cisco ASA IPS IDS have system for automatic defense against zero-day polymorphic worms and automatically generate the signatures? No, I don't. I would say personally no, they do not. There is some talk about that, but I don't believe that to be the case. I haven't seen that in action, so I can't 100% confirm or deny, but I would suspect the answer to that would be no based on my experience with it. Okay, so moving to the next slide, let's have a look. So IDS and IPS types and options. Okay, so we've pretty much spoken about these, but this is just in a nice pretty table. So we've got our deployment options. Oh, that first column didn't turn out very well, did it? So we've got our deployment options, that is the first criteria, and approaches to identifying malicious traffic is our second criteria. So if we just look at the deployment options for a start, we can go network-based or host-based. Okay, so the ones we've been mainly talking about thus far has been network-based, where your sensors can scan traffic that is destined to many hosts. So whether that's with an IDS sitting off to the side and just listening through a promiscuous interface, or whether it's an intrusion prevention system, IPS, sitting in line with an in and out interface, that's a network-based device, okay? And that can be either an appliance, a router, you know, a PC that you've got Snort running on, if you want to look at it that way. That's obviously not particularly relevant for the Cisco exam, but it's still a valid product that you can use. And then we have host-based, okay, which is basically where you install a piece of software, an agent, on your operating system, and in the Cisco world these are available for both Windows and Unix, Linux-based platforms. And that host agent will monitor all the operations within that operating system to check for the presence of malicious traffic or programs or access. In terms of if we look at the second criteria now, the approaches to identifying malicious traffic, you can see there's 4 based there. So we've had a bit of a look at the first 3 really. So your signature based, it's basically a vendor provides you a customizable signature database. So again, this is a bit like your AV subscription, downloading your signatures fairly regularly, same sort of thing. Policy-based, policy definition and description is created, so that's done by you, and you can determine what your policies are and what you want to block and don't block. Anomaly-based, normal and abnormal traffic is defined. Now again, there are some, and these can be used in combination, okay, so it's not a one or the other, or they can be used in combination, either with separate devices or within the same device. So anomaly-based is basically you deciding after you've given the device an opportunity to learn about what's going on in the network, you can specify to it what is normal and what is abnormal. And then lastly, always a fascinating topic for discussion and a fascinating area of research is the honeypot-based, where you basically set up a sacrificial host or a sacrificial lamb, and you put it in a completely unguarded, unprotected, obvious area in your network, and you lure your attackers to attack that particular host. And it's absolutely amazing, well it was to me the first time it happened, how quickly an exposed host is found on the internet and has people doing something. So whether it's a, whether it's a particular just port scanning or enumeration, or whether it's a denial of service attack or someone getting onto it and doing all sorts of random things. It's really, really interesting to have a look at. Of course, honeypots need to be a long way away from your real network, because the last thing you want is someone to jump on a honeypot, gain access to it, and then from that bounce into your network, which sounds pretty obvious, but I've seen it happen before. So interesting thing to use. Again, not a heck of a lot of that covered in the actual CCNA security exam itself. So NIPS and HIPS. So network IPS and host IPS. So network IPS, network-based system or network intrusion prevention system, where the IPS analyzes individual packets that flow through a network. Okay, so we've already spoken about this at length tonight. Your HIPS, on the other hand, is host-based intrusion prevention system. So it's still an intrusion prevention system, but it's now residing on your host rather than on a network device in the center of your network. So it examines the activity on each individual computer or host that you have the agent software installed on. It has full access to the internal information of the end station, and it can relate incoming traffic to the activity on the end station to understand the context of that traffic. So if, for instance, if you have it installed on your Linux host and you are remotely accessing that via SSH, then it will be able to see that traffic coming in, think about what's going on the actual host at the time, and put it all into a context where it can intelligently, hopefully, understand what's actually happening. So in VPN environments where encrypted traffic flows through the network, the HIPS is the only option to examine traffic in plain text, because obviously as it's coming through the network devices through the network IPS, then it's encrypted, so the device can't see it. HIPS typically apply to a specific operating system, and it doesn't protect against lower level attacks, such as attacks specifically targeted to layers 1 through 3 on the OSI model. So we're talking physical, data link, and networking. Okay, so if there's attacks actually specifically aimed at those 3 layers on your device, then a HIPS is not going to pick that up. A NIPS will, but a HIPS won't. I should say a NIPS might. Another disadvantage of the HIPS is that the attacker, if they've done enough reconnaissance and know enough about your system, can detect the host existence and probably even discover that the host is being protected by HIPS. And if they know that, then it's possible that they could then circumvent it in some way. So HIPS are complex, and they examine actual system calls, or can be simple and just examine system log files. Okay, so it can actually look into the operations of the actual operating system itself and what's going on all the time, or it can just look at log files. Nice and simple. Some host-based monitoring systems can halt attacks before the attacks can succeed, whereas others only report on what's already happened. So the Cisco implementation of HIPS uses a thing called the Cisco Security Agent, or CSA, that you deploy on your protected hosts, and the CSA will then report their actions, whatever they do, back to a central management console, okay, which is Cisco Security Agent Management Center, so CSA MC. So if you see that, that's what that means. Okay, if we do a little bit of a comparison between HIPS and NIPS. So HIPS and NIPS are complementary to each other. Okay, so the two-ended arrow here in the diagram really is just representing the relative weight that each of these systems place on specific functions. A general statement, as in general, NIPS will focus on detecting things like buffer overflows, attacks on web servers, network reconnaissance, and denial of service attacks, while HIPS will focus on application and actual protection of the resources on that specific host that it's installed on. A huge advantage of HIPS is that HIPS can monitor operating system processes directly and protect the system resources, including files, that may only exist on that specific host. Okay, whereas obviously network IPS can't do that. HIPS is a combination of behavioral analysis and signature filters. It can also combine the best features of AV, network firewalls and application firewalls in one single package. So a simple form of HIPS enables system logging and log analysis on the host. However, this approach can be very, very labor intensive. Okay, so the software agent that you install on each host to monitor activity you have to have that software on your actual host. Okay, so it's obviously not going to do it on its own. NIPS features. Okay, so NIPS again, network IPS. As we've said, involves deploying monitoring devices or sensors throughout your network. They detect that initial malicious traffic and unauthorized activity in real time and take action if it's required. They're deployed at designated network points, which again is determined by your particular design. And this enables you to monitor the network traffic while the activity occurs, regardless of the location of the target of the attack. Okay, so wherever and this is a thing that harks back to the design. Okay, the careful way that you need to put your design together, that needs to be done with a lot of thought, because where you place your IPS or IDS will determine what you can and can't see clearly. So if you've got an area where where access can be granted from external locations and your IDS or your IPS can't see it, then obviously it's not going to be able to protect against it. So requirements of a good IPS, you're going to need, let's just put everything up there, you're going to need, and again this is if we're talking about iOS IPS, or if you're talking about IPS that you install on a system of your own choosing, then obviously they need to have network interface cards that are going to be quick enough to provide you with the service and the expected bandwidth that you want. You're going to need plenty of processing power, because obviously as it's going through the traffic and analysing this traffic, it can take a lot of processing power. So you need a fair bit of grunt. And then lastly, you need something with a lot of memory as well, because detection of anomalous traffic or traffic flowing through a network can take an awful lot of memory. So if we look at some deployment, if we just quickly have a look at this particular graphic, so what we're looking at here, it's just an example configuration of a NIDS and NIPS deployment. The placement of as I said before, the placement of the sensors within the network is pretty important. You need to deploy your sensors at the network entry points that protect critical network segments. So you can see here, we've got the untrusted network on the right here going through a firewall. There's DMZ down here where we have our web servers and our DNS servers. That's a pretty obvious place to have a NIPS or a NIPS in this case, or a NIDS. Through your router, they've also got another IPS sitting in line to protect, and you'll see why, because we've got two routers here and in between we've got a management server sitting. So we need to have some protection for that. And then on your internal trusted network we have an IDS. Okay, so we're not going to slow down the traffic coming from the trusted network, because if you think of this, I'll just turn my highlighter on for a second, spotlight on rather. If we look at this particular router here, that these trusted network here could actually be represented by a number of different VLANs going into a layer 3 multi-chassis switch. So you don't want to have an IPS in line with all of that, because it could get rather messy and rather noisy. So you would simply have an IDS on the inside of your network, having a bit of a look around in there and keeping an eye on traffic there. Okay, so if we look at signature-based IDS and IPS just quickly, so signature-based pattern matching basically refers to searching, actually I'll put up that whole slide there we go, basically refers to searching for predefined content or a fixed sequence of bytes within a single packet. So the signature-based approach is fairly strict, but it's simple to employ. So in most cases the signature pattern is matched only if the suspect packet is associated with a particular service, or more correctly, destined to or from a particular TCP/UDP port. So this method will decrease the amount of inspection that the network performs on every packet. However, it does make it more difficult for systems to deal with protocols that don't reside on well-defined ports. Okay, so if you've got a web server running on some other unusual port, then it's going to make it more difficult to detect that. It makes it more difficult for systems to deal with those protocols not on defined ports, and in particular Trojan horses and their associated traffic, which can be usually can be moved at will. So to determine an attack signature, which is usually a well-known pattern of attack, an IDS and IPS will inspect the packet headers or data payloads and match them against the signatures within the database. So the signature is really just a string, as we said before, a string of bytes within a certain context. Now the context may be the position of the sequence within a specific data flow. It could be a part of a valid command in the application layer protocol, okay, so part of, say, in this case, a GET HTTP request. Or it can be a combination of the options that are within an IP datagram. So signature-based devices will only detect attacks that have been entered, of course, into the database by the vendor or an administrator. So usually they're unable to detect undiscovered or unreported attacks, hence day zero attacks. Therefore, all signature-based IDS and IPSs place a certain amount of burden on the administrators to make sure that signatures are regularly updated and that they're configured correctly. So typically Cisco will publish the database updates, but you've still got to go and make sure that they are applied to your particular devices. Okay, so looking at policy-based IDS and IPS. Yep, there we go. So the policy-based approach basically uses an algorithm to base the alarm decisions on. So an example of this type of policy is something that's used to, say, detect a port sweep. Okay, so as we can see in the diagram here. So basically it'll look for the presence of a threshold number of unique ports being scanned on a particular machine. You can also further restrict it through the specification of the types of packets that the policy is actually interested in. For example, you can say, right, well, I'm only interested in looking at SYN packets, nothing else, that's all I'm looking at. So there can also be a requirement that all probes must originate from a single source. So if you've got multiple sources, which is common, some forms of attacks, multiple sources sending out probes all the time, then that comes up as being a no-no. So policies of this type require that some threshold manipulations are made to make them to conform to the usage patterns on the network that they're monitoring. So again, you've got to do some configuration. You can't just put it in holus bolus and hope that it's worked. So you can use these policies to look for very simple statistical events or complex relationships. So either way, they're going to work. Policy-based policies will block the traffic or send an alarm if a violation or configured policy occurs. Policy-based system is a popular method for the detection, especially if unknown attacks need to be detected. Policy-based IDS and IPS need to have a clear representation of what the security policy is. Okay, so you need to, same sort of thing as when you're looking up, when you're building a policy for your firewall, you need to make sure that you specify exactly what it is that you want them to do, exactly what it is, and then have some consistent foundation for that application of that particular policy. So some policies, however, you need to be cognizant of the fact that some policies are hard or almost impossible to incorporate into IDS and IPS anyway. For example, if your staff are browsing pornographic websites, hacking or wares sites, the system must be able to communicate with some type of blacklist database for that to work. Okay, so they can't actually do much for that on their own. So anomaly-based IDS and IPS, so moving into the next one. So in this case, signatures will look for network traffic that deviates from what is considered normal or regular. So what is configured normal, what is considered normal. So the main issue regarding using this method is the definition is what is a definition of normal. So some very few systems, but some systems do have hard-coded definitions of normal traffic patterns, but by and large most networks are ever-changing. Okay, they're not the same all the time. And as I said before, one of the problems is not giving your device long enough to actually learn about the traffic flows within your particular network. And if you don't do that, then there's always the opportunity for false positives to pop their heads up. Okay, so we know that anomaly-based will monitor the network for events and content that represents something different. They include, so an anomaly will usually include an increase in a certain type of traffic, an occurrence of some type of traffic that's not normally there, or something within a known protocol that's not quite right. So a malformed packet or a packet that's been changed to do something outside what it should be doing. The other thing you need to know about anomaly detection is that there's two types of anomaly-based detection methods. So the first one is statistical anomaly detection. So with statistical anomaly-based detection, the system will learn about the profile of the monitored network, or the traffic patterns that go on, from the network itself over a period of time. Okay, so again, it's based on statistics, and this is what I'm saying. Often people don't give enough time for their device to learn about their traffic. Okay, that's the case with statistical-based anomaly detection. After the period where it's learned about what traffic is typical for your network, then it can detect anomalies based on the statistical properties of the network traffic. Okay, so if the statistical properties of your network traffic start to deviate too far based on thresholds that you configure from what it considers to be normal, then it will jump into effect and do something, whatever you configure it to do. The other one, okay, so we've got statistical. Guess what the other one is? Non-statistical, right. So it's basically uses a predefined definition of what known good behavior is, usually coded by Cisco, and triggers where an event outside such a profile will occur. Okay, so again, it's a very strict definition of what normal is. Lastly, our Honeypot-based IDS and IPS. Okay, and as you can see here, Mr. Honeypot is sitting right out here, all on his lonesome. Okay, so he's very well, he's very unprotected. So Honeypot systems provide that dummy server, okay, to attract attackers, hence like bees around a honeypot. The philosophy of the approach is to basically distract attackers away from the real network devices. So there's some debate about whether that's security, obscurity, blah 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 blah. But I think they certainly have their point, and certainly have their place. And in terms of research, honeypots are absolute gold because they allow you to detect. A lot of vendors will use them as basically detection methods for zero-day attacks. So something will come out, oh, we don't know about that. Okay, now we've got a sample of it. Now we can develop some fixes or some signatures that we can push out to our customer devices, and away we go. You're not going to see a heck of a lot about honeypots on the exam, so we won't sort of jump into that too much more. Signature categories. Really don't want to talk too much about this, but I'll whip through these. So your signature is basically a pattern, okay? It's basically a pattern of traffic that your device needs to look for. There are 4 categories of signatures. So there's exploit signatures, and do we have them? Yes, we have them listed there. Exploit signatures, which obviously are a signature of specific exploits. So if those particular, so they're unique to a specific exploit, and each exploit, as we know, each exploit can have variants because things change over time. An exploit, you can write a fix for it, but someone will come along and they'll have a variant to that exploit and make it a little different. So attackers can bypass detection by slightly modifying attack payload. Okay, therefore, you often must produce an exploit signature for each attack tool variant. Okay, so there's always going to be that variation. Then there's connection signatures. So they generate an alarm based on the conformity and validity of the network connections and the protocols. Okay, so that one's a pretty straightforward. String signatures, they support regular expression pattern matching and have alarm functionality built in. And denial of service signatures, which contain behavior descriptions that are considered characteristic of specific denial of service attacks. So when your bogus traffic passes through your sensor, one or more of the sensor microengines, as they're called, are activated to inspect the data. Each microengine will control one of these sets of signatures. And then the sensor's got to decide which microengine to activate to scan the associated signatures. And this selection is based on 4 different criteria. So the network protocol of the traversing traffic, okay, so whether it's IP, TCP, UDP, whatever, the type of the operating system the signature may be associated with, the session port, and the type of the attack. So if we're talking about IPS sensor platforms such as, the old 4200 series, or some of the more recent series, there's around about 2,500 signatures available, and there's slightly less for the IPS. And I'll post up some more. I'll just make a note of that because I'll post up some detail. You might actually find that interesting. I'll make a note to post up some resources, just some Cisco stats on number of signatures available. And also on those I'll just make a note for that throughput rate too, because I think that was an interesting question earlier. Again, it's just for interest. It's part of the course. It's part of our MOOC course here, not necessarily part of the requirements for the Cisco exam. Okay, exploit signatures. So the type of exploit signature can be matched with the level of the operating system. Exploit-specific signatures will seek to identify network activity or upper-level protocol transactions that are particularly unique to a specific exploit or attack tool. And you can see in the diagram here, application, there's some examples there to look at. Transport, there's some examples. Network, there's some examples there. Okay, so the specificity, if I can get that out, of exploit signatures provide an analyst, so you guys, with some instant insight into that methodology of an attack and may allow you to then identify and mitigate the targeted vulnerabilities, okay, not just through your device but actually on the end system itself. Your exploit signatures are often pretty easy to produce for simple protocols and attacks and are often simply just employed using pattern matching. And again, we've got, as I said, we've got some exploits here based on the OSI model. Oh, leave that one out. So signature examples, these are just some examples of signatures so that are part of the Cisco database. And again, that first column didn't turn out that great. So 1101, unknown IP protocol. This signature will trigger when an IP datagram is received with the protocol field set to 134 or greater because it's bogus. TCP window size variation, signature will file when the TCP window varies in a suspect manner. TCP SYN port sweep, so signature triggers when a series of TCP SYN packets have been sent to a number of different destination ports on a specific host. So it's someone obviously sitting out there running some sort of tool which is just, asking, is this port alive, is that port alive, is this port alive, is that port alive? And last one, HTML script bug, it'll trigger when an attempt is made to view files above the HTML root directory. Okay, so they're just some examples, some of the examples of signatures that are available, and obviously there's a bucket load more. Okay, so last thing I wanted to go through tonight was a lab, a packet tracer, just a basic, and it is a very rudimentary lab, but it's still worthwhile having a bit of a look at, and it'll give you some of an idea of some of the commands and some of the ways in which an iOS device can be configured as a rudimentary IPS. So obviously I haven't got a IPS sensor appliance sitting here in my office. Unfortunately, I wish I did so I could show you that, but I haven't. So we're just going to use Packet Tracer to have a look at a bit of what is possible in a small scale network. Okay, now notice that there are a few other questions which I might answer in a second. Some of them may be answered by the lab. If not, if I've missed your question somewhere along the way this evening, please feel free to pop it up onto the portals. Okay, so if we look at our network diagram, whoop, wrong way. Let's just move this over a little bit. Okay, so if we look at our network diagram this evening, this is what we're going to deal with. Now, I actually haven't been through this lab, so let's I'll get the notes up here and we'll actually have a bit of a look. I'll read a bit about what actually we have to do here. So this is a on-the-fly thing, so anything can happen and probably will. So if we look through it, okay, we need to learning objectives for this lab. We need to enable iOS IPS, we need to configure some logging, modify a signature, and then verify that it works. Okay, sounds pretty straightforward, yeah? So here he says, so the task is to configure router 1, so that's here, router 1. Okay, CLI, so I'll just log in. So in case you're not already aware, and I hope you will be because you're already using these devices, well, I hope you're already using the Packet Tracer Labs. The passwords are Cisco VTY PA55 for telnet password. For enable password, it's EN PA55. So I have written that up on the forum somewhere, but I often get questions about it, so I thought I'd just answer them while I'm here. Oh, and the console one is Cisco Con PA55. All right, so the server, if we look at our diagram, the server labeled syslog server, so over here, is used to log our IPS messages. We must configure a router to identify the syslog server in order to receive the logging messages. Okay, so that's fine. We just have to set up a bit of logging there. It's easy. We need to display the correct time and date stamps in syslog messages. Okay, that makes sense again, because if we don't, then what's the point in getting a log message if we can't correlate it with a specific event or a specific time? If we can't do that, then it's a bit of a waste of time. So we need to set the clock and configure timestamp servicing for logging on the routers, and then finally we need to enable IPS to produce an alert and drop ICMP echo reply packets. Okay, so we're not going to allow ping, so we're not being very friendly. Okay, so what's the first thing we want to do? So we want to verify the network connectivity. So we want to ping from PC1, PCA to PCC. So if I look up the IP address of, so I'm on PCA, if I look up the IP address of PCC, it's 192.168.1.2. Okay, bingo, we know we can connect through to our mate there. And then, because we're paranoid, we'll just do it back the other way, which seems a little bit silly because, let's face it, if it goes one way, it's probably going to go the other. Okay, there we go. So we're happy with that. Okay, so next to our router 1. Wow, this is a little bit, okay, this is good. So what we're saying is what we need to do is, on router 1, we need to, what's it say? Create a directory in Flash using the make directory command and name the directory IPS directory. Okay. So if we look at that, so we go Flash. So remember, guys, don't know whether you should all know this, but just in case you don't, if you use a question mark, you will always see what's available, what commands are available. Now, the reason I use this in Packet Tracer is often because I'm an old fella who's been around Cisco environments for quite a while. Some of the commands that I might use to do something are not actually available in Packet Tracer, so I need to make sure that I don't look completely foolish when I'm doing these things. So make directory, make directory flash, and we're going to call, what's it called? We're going to call it, what was it? IPS dir. Okay, done. So if we go dir flash, hopefully it's there. There it is, IPS dir. Excellent. Okay, so on next step is to configure the IPS signature storage locations to be the directory that you actually use. Okay, so let's see how we do that. So let's say we've got no idea. Whoop, hang on, what am I doing? I need to be in configuration mode, you idiot. Okay, so IP, let's have a look. IPS is a pretty obvious command, and we've got config, and I reckon the next keyword is probably location. There it is. And then I reckon the next thing we need to put in is a flash directory. We do. So flash IPS dir slash, then what else does it say? Okay, what are the other options? Retries. Okay, we'll give it a retry of 1. We'll say, all right, you can have 1 go at it, and that's it. Okay, done. Step 4, we then need to create an IPS rule using the name IPS name, configured in global configuration, name the IPS rule IOS IPS. Okay, so that's pretty straightforward. So IPS name IOS IPS. Done. Okay, so this is all looking fairly easy, isn't it, guys? Okay, so we need to enable logging to the logging server, which is 192.168.1.50. Do that next. So logging trap. Let's put in debugging traps. Do everything, and we're going to log to 192.168.1.50. Okay, there we go. So it's gone off and initiated, and it's all happy. Okay, so next step. We need to use our clock set, of course, don't we? I forgot about that. Clock set. Oh, you idiot. Yep, can't spell. Clock. Set. I can never remember this. So what is the time? Is 20:04:00. Oh, of course, you goose. And it is, what's the date, everyone? It is the 8th of September. 8 September 2014. Okay, so there's our clock set. So if we go show clock, thankfully it's good. We're set at UTC, but anyway, we'll move it on. That's fine. So then the next step is we need to okay, so next step, so we've configured we've got our logging going, we've got our clock set, everything's happy. We need to then configure the IOS IPS to use the signature categories. So we need to retire the all signature category with a retire true command, and then unretire the IOS IPS basic category. Okay. So back into configuration command, will it be IPS signature category. Yep. Okay, so what did I say? Retire category all. So category all would be retired true. Okay, so that means it's inactive. Category, what do we have to name it? IOS _ IPS basic retired false. Okay, so now it's ready to go. So there we've got our IPS. That's our basic IPS configuration. Okay, so really basic. Obviously, it's a very basic one. Okay, but that's right. We're going to. I think we're going to change the signature a bit later on. So now, of course, a bit like an ACL, we've now created that particular, we're now told the IPS that we want to use those particular signatures, but conf, that's better, conf key, but we need to actually apply that somewhere, otherwise it's completely useless. So we're going to apply that to our fast Ethernet 00 interface, and we're going to use the, I've got to remember, IPS, and what was the name? IOS IPS in the outbound direction. Yep. Good. Okay. So now it's active or active. Exciting stuff. Okay, so next, oh, what am I doing here? I'm getting bent all out of shape. Where did that go? Okay, so what's the next part we need to do? Next part. Okay. Okay, use the, let's have a look what we've got. IP, IPS, all. Oh, all. I can't even spell all. That's a bit ordinary, isn't it, guys? Okay, so all. And we'll just make this a little bigger so we can see. So what have we got? IPS signature file configuration, status, configured locations in IPS DIR. Total active signatures 1. Here's our IPS name that we configured before. IPS fail closed is disabled. Okay, so it's not going to fail closed, it's going to fail open, which is usually a better thing than failing it closed. Whatever other, okay, and then we can see on our inbound Ethernet interface, we've got the outgoing IPS rule is IO SIPS. Okay, so now if we pop back to our, don't want the web browser, ping. Okay, so you can see our ping is, hang on, have I missed a step here? Let's have a look at what our idea, now what I want to do here is I don't think it actually mentions this in the lab. Let's have a look. No, doesn't mention it. Okay, all right. So what I want to do, I'll just see whether this works. I'm wondering whether they actually allowed us to run debug information, because I think it'd be interesting to have a look. No. Okay, so it's not there. Alright, so that's the end of that. That didn't work very well. So now if we go back to our log server and services, desktop, syslog, you can see here there are some events. Okay, so these are our events that have been logged through from the router through to our syslog server. So you can see it's fairly rudimentary. It's fairly basic. Okay, there's not a lot that you can do with it. Well, with this particular packet tracer lab, but that gives you a basic idea of the sort of things that you can do. Okay, so it all comes down to, if I just bear with me for a sec, close down a couple of these windows. We don't want that anymore. Okay, so we go back to here. So if we have a look at the running config, you see, pretty simple, pretty straightforward. This is basically it there. That's your basic IPS signatures, your name, your config location, so on and so forth. And then you've got the application of the actual IPS onto the fast Ethernet interface there. So you can see that it's a fairly basic configuration. You can obviously do more with it based on what signatures you want to enable or as it says, retire or unretire. And that's something that you would need to look at more in detail. You'd need to look at more in detail in combination with the Cisco documentation for your relevant version of iOS. Again, as we said earlier, and you'll hear me say a lot if you do security courses with us as well, is that you always need to make sure that you have a policy defined. What is it you're trying to achieve? What are you trying to look at? What are you trying to defend your network against? And then base your IPS configuration on your router based on that, okay? Rather than just getting in there all holus bolus and typing lots of commands in. Have a plan. Have a plan. Work out what you want to protect against. Find out, look at the Cisco documentation, find out a bit about the signatures, and then apply what you need based on what you require. So that is pretty much it for this evening in terms of the lab and the lecture. As I said, it's a fairly no, we don't want to say that. It's a fairly simple sort of configuration on the iOS devices. You don't need to know a lot about the appliances, and you don't need to know a lot about the service modules or the network modules. What you do need to understand a little bit about is how it's implemented in the iOS. So that lab will help you to do that, as well as having a look at some of the readings up on the web page. A couple of people have asked me about whether I would recommend a particular training guides or whatever for the CCNA security exam. Look, I'm a bit old-fashioned. I like the genuine Cisco Press ones, and Cisco Press have a really good one out that is basically, I've got a PDF version of it here that I can open and just give you the title of it. I'll go away. So the title of this one in particular is just the CCNA Security Official Cert Guide. So it's exam number 640554. That's a current exam guide now. So if you want to get hold of that, that will go into a little more depth on the IDS IPS than what we can cover in one lecture in a single week. But it basically covers the same sort of stuff that we've looked at tonight. So I'll pop up, as I said, those couple of articles that I was talking about earlier and some links to give you some information about throughput and some of the technologies available on the iOS. And obviously the PDF versions of the slides are already up there for you to look at should you so desire, as well as the video, which will be coming in the next 24 hours. So next week will be our last week before the test. So we're going to look at some VPN and crypto, so the basic fundamentals of crypto, what makes up crypto, the different phases of it and the different configurations for it. And then we're going to look at an example of a point-to-point VPN. So we're not going to be doing any remote access type stuff. It's going to be a point-to-point VPN just as the example. And then after next week, the week after that, the exam will go, so the exam for the MOOC will go online. And you'll be able to, that'll be 50 questions, multiple choice, around about 10 questions from each week as we go through, and you just need to work your way through that and successfully beat the cutoff score, which I think from memory is going to be 70%, something like, don't quote me on that, but it's around about that. So if you beat that score, then you will be entitled to a IT Masters CCNA Security MOOC completion certificate. Once again, this MOOC will not prepare you 100% for the CCNA security exam, the official exam. Obviously there's a lot more material that you would need to cover, which cannot be covered in 5 1-hour or 1.5-hour lectures each week. So there is a lot of ground to cover, and particularly if your networking background isn't particularly strong. I know we've got some people who are part of this MOOC who haven't got Cisco CCNA certification or that level, and that's fine, you'll get something out of it, but it's really aimed at those who have got CCNA level certification and are keen to go on to do the CCNA security. So that's enough from me tonight. Next week, VPN and crypto, same time, same place. Otherwise, if you have any further questions, pop them up onto the forums and I'll do my best to answer them, or perhaps other students will be able to answer them. Otherwise, thank you for attending, and good evening.